Hello everyone, in this video we're going to talk about remainder theorem and factor theorem. I have three questions for you today. Number one, what is the remainder when 4x to the third plus 3x plus 4 is divided by x minus 1? So you could actually do long division or synthetic division on this to divide it out, but there's actually a theorem that we can use called the remainder theorem. So if you take what we're dividing by and set it equal to 0, that ends up getting x is 1. And if you take the value that you just got, in this case 1, and you plug it into all the x's in the problem, that will tell you what the remainder is. So if we do 4 times 1 to the third plus 3 times 1 plus 4, if we evaluate this, we get 1 to the third, which is 1, times 4. 3 times 1 is 3, plus 4. We plug that in and we evaluate it, we get 11. That means the remainder, if I were to actually do the division, the remainder on that one works out to be 11. Like I said, you could actually divide it out, but this theorem lets you not actually do all the work that it would take you a lot longer to do. So, again, to recap, take what's doing the dividing, set it equal to 0 to get the value of x. The value you find is what makes 0, right? 1 minus 1 is 0. And then you put that value in, so change all the x's to 1, and that will tell you what the remainder is. Example number 2 says x plus 3 is a factor of x to the third minus 5x plus k. What is the value of k? So, when something is a factor, the remainder is 0. So, we're going to use that fact. We're going to say, if I were to put in x plus 3 is 0, x equals negative 3. If I put in negative 3 into this problem, negative 3 to the third minus 5 times negative 3 plus k, they're telling us when I put in this negative 3, since it's a factor, the remainder is 0. So that's a fact that you need to know for this lesson. When you're dividing, if the remainder is 0, that means that the thing you divided by is a factor. So that means x plus 3 goes into this, so the remainder is 0. So now let's just change all this and see if we can find what the value of k is. So negative 3 to the third is negative 27. Negative 5 times negative 3 is 15. Plus k equals 0. If I solve this for k, if I do negative 27 plus 15, that's negative 12. And then if I move it over there, k is equal to 12. So in this question, k is equal to 12. And then last question for today, which one is not a factor of this polynomial here? So remember, if something is a factor, it has a remainder of 0. So if this is a factor, that means if I put in x minus 1 equals 0, x equals 1. If I put in x equals 1 into this problem and it makes 0, then I know that this is a factor because that would make a remainder of 0. So let's do that. 1 to the third minus 3 times 1 squared minus 13 times 1 plus 15. If I evaluate this with my calculator, it's going to work out to 0, I believe. Let me just confirm. 1 to the third minus 3 times 1 squared minus 13 times 1 plus 15. Hey, look at that. It worked out to 0. So that means this is a factor. We want the one that's not a factor. So let's do this one. X plus 3 equals 0. So x equals negative 3. If we change all of the x's in this problem to negative 3, we get that big expression. Let's see what we get when we change all those to be negative 3. We got 0. So that one is also not a factor, so we can cross off those two. Let's try this one. Or sorry, that one is a factor. Let's try this one. If we plug in x equals 5. So for this one, I'm going to go to the y equals screen, and I'm just going to type in x to the third minus 3x squared minus 13x plus 15. If I go to the table, then I don't have to keep writing this out, and I don't have to keep typing in all the answers. If I go to the table, I can just look and I can see which values make 0. 5 makes 0. When x is 5, y is 0, so I know that one's out. It must be choice D. And actually, when I plug in x is negative 7, it looks like I get 120. Oops. No, that's positive 7. When I get x is negative 7, I get y is equal to negative 384. So choice D is my answer. So instead of typing the problem over and over and over again, you could just put this into the y equals screen and then test out the values just by looking in the table. That's it for today. Thanks for watching.